right, this example looks a lot like example 3. We have a circle of radius r centered at the origin on a coordinate plane, and it says to consider this circle and give the radian measure of each quadrant angle. Okay, so if you remember, the quadrant angles are the angles where the terminal side lies on the axes, right? So like 0 degrees, the terminal side and the initial side lie along the positive x-axis. So again, we have no no fraction of a rotation. The arc length is 0, and so the angle measured in radians is also 0. All right, that's not very interesting, but let's see, 90 degrees, we said that was a quarter of the circle, right? So a quarter of the circle, we had 1/4 of the way around the circle. That was 1/4 of the circumference, right? So let's just write down what we had before. 1/4 of 2 pi r, right, gave us pi over 2r. Okay. Now, remember that the angle in radians is equal to s over r, right? That's the definition of the radian measure of an angle. So if we take the s, which is arc length, and divide it by r, we get pi over 2 r divided by r. The r's will cancel, and we'll just get pi over 2. Okay, so 1/4 90 degrees is equivalent to pi over 2 radians. All right, 180 degrees, now we're half of the way around the circle. If we take 1/2 of 2 pi r, remember we got pi times r. Okay, and again, if we just take the arc length divided by the radius, take pi times r divided by r, we're just going to get pi. Okay, so 180 degrees is pi radians. Let's mark these on the circle here. So this is 90 degrees, but it's also pi radians. Okay, this was 100. Sorry, that's not pi radians. It's pi over 2 radians, right? Pi over 2 radians. And 180 degrees is pi radians. All right, let's keep going. 270 degrees was 3/4 of the way around the circle. So 3/4 of the circumference, 2 pi r, is going to give us 3 pi over 2r. Okay, so again, to find the radian measure of 270 degrees, we're just going to take 3 pi over 2r divided by r, and we'll end up with 3 pi over 2. Okay, so 3 pi over 2 is equivalent to 270 degrees. Now, 360 degrees, of course, is one full rotation. The arc length would be the circumference, 2 pi r, and if we want the radian measure of 360 degrees, we take 2 pi r and divide it by r, and we'll get 2 pi. All right, so let's go ahead and put those on the circle. So down here at 270 degrees, this is equivalent to 3 pi over 2 radians. And then over here at 360 degrees, which is also 0, right? So this is 0 as 0 radians, and it's coterminal. We'll talk about coterminal in a minute. It's also equivalent to 2 pi radians. That's one full rotation, okay? So there we go. We have all the quadrant angles marked. Now, we're going to talk next about converting between degrees and radians, but let me scroll down here a minute. So if you remember, we had from example 3, part B, we had that the arc length was, we got pi over 180 times the angle in degrees, and then times r. Okay, so now we also know that the arc length is the angle in radians times r. So this right here, this part right here, let me scroll down just a little more to give me some room. This right here is theta in radians, right? So we have theta in radians is equal to pi over 180 times the angle in degrees. Okay, so we're going to use that in the next example. So I'll meet you there.